Why does a partially submerged cylindrical pendulum oscillate perpendicular to a flowing stream? As vortices shed alternately from the two sides of the cylinder, the pressure switches from side to side and creates a periodic transverse lift force. When the shedding frequency approaches the pendulum's natural frequency, the response can become much larger. That is the central resonance chain in this problem. Our model shows that flow speed and cylinder diameter affect both the forcing strength and the shedding frequency. Immersion length mainly changes the lift amplitude. Pendulum length controls the natural frequency. For the baseline case, the simulated Strohel number is about 0.179, and the shedding frequency is about 0.859 Hz. Close to the finite channel theoretical correction, the full material includes flow fields, vorticity, lift spectra, pendulum response, parameter sweeps, and theory simulation comparisons.